Good morning. This is the third session of basic thermodynamics. In this session, we will discuss about zeroth law of thermodynamics. So basically, zeroth law of thermodynamics deals with concept of temperature. Means concept of temperature comes from zeroth law of thermodynamics. Before understanding the basic about zeroth law of thermodynamics, first of all, let me clear some basic concept regarding thermal equilibrium. So we have already discussed about thermal equilibrium in previous classes, that thermal equilibrium basically stands for equity of temperature. That means if two bodies A and B have equal temperature, in that condition body A and body B will be in thermal equilibrium. So there should be equity of temperature between two bodies for to be in thermal equilibrium. So concept of thermal equilibrium is very important for understanding the zeroth law of thermodynamics. Okay. Now we will come on the basic gist of basic fundamental of zeroth law of thermodynamics. In this figure, there are three bodies: body A, body B, and body C. T is the temperature of A, Tb is the temperature of body B, and Tc is the temperature C. As per basic gist, basic concept of zeroth law, if body A and body B have equal temperature, that means body A and body B will be in thermal equilibrium. And if body B and C are also in thermal equilibrium, that means both body B and C have equal temperature. In that condition, body A and C will also be in thermal equilibrium. That means if Ta is equal to Tb, in other words, it can be said that if Ta is equal to Tb, in that condition body A and B are in thermal equilibrium. And if Tb is equal to Tc, in that condition it can be said that body B and C are in thermal equilibrium. In this condition, body A and C will also be in thermal equilibrium. That means body A and body C will have equal temperature. So if Ta is equal to Tb and Tb is equal to Tc, in that condition Ta is equal to Tc. This is the basic fundamental of zeroth law of thermodynamics. Okay, so it is clearly written as in this section at the statement of zeroth law. If body A is in thermal equilibrium with body B and body B is in thermal equilibrium with body C separately, then body A and C are in thermal equilibrium. Okay, now we'll move towards the term thermometric properties. This is very important, thermometric properties. You know that from basic equation PV is equal to mRT. This is the ideal gas equation, PV is equal to mRT. In this equation, it can be understood that, it can be seen that for fixed M and R, this temperature is function of pressure and volume. So in this, it is clear that temperature is function of pressure and volume. So basically thermometric property, basically what does it say that? Thermometric properties are the variables. Thermometric properties are variables which are used in measurement of temperature. Means this temperature is function of pressure and volume. That means this pressure and volume are thermometric properties, because these variables are used in measurement of temperature. So temperature depends on pressure and volume. Therefore this pressure and volume will be thermometric properties, because measurement of temperature depends upon pressure and volume. So this is thermometric property. So it is written in this definition: the variables which is used in measurement of temperature is known as thermometric properties. Now in next section, in next page is this as we have already discussed that the concept of temperature comes from the statement of zeroth law of thermodynamics. So this temperature measurement is very important. So as we know that the temperature is measured by the help of thermometers. So in another word, it can be said that the concept of thermometer comes from zeroth law of thermodynamics. This is very important. So this question can be said in different ways. Somewhere it can be said that concept of temperature comes from zeroth law of thermodynamics. At the same time, concept of thermometer develops from zeroth law of thermodynamics. Okay. Now, as we have discussed, this temperature measurement is important. So there are two references. One reference is the temperature measurement before 1954, and next reference is temperature measurement after 1954. So here, before 1954, some different reference temperature were being used, and after 1954, some different reference temperature were being used. So first of all, we will discuss methods used before 1954. Before 1954, basically there are two reference temperatures. One is ice point and another one is steam point. Two reference temperatures were being used. Okay, so remember, before 1954, two reference temperatures were being used. One was ice point and next was steam point. Ice point, we know 0 degree centigrade is ice point and 100 degree centigrade is steam point. So in this condition, this temperature will be linearly in that condition. The temperature is function of varies linear temperature that is linear. As we know that we have seen in some domestic thermometer, in this it is clearly seen that the length of Hg column decides the temperature. Okay, as temperature increases, the length of Hg column increases. So this length of Hg column decides the temperature. So in that condition, before 1954, this temperature is function of distance. Okay, length of column, length of Hg column. So T is equal to Ax plus B. This is the basic equation. We know when x is equal to when T will be ice point, in that condition x will be xi, and when T will be steam point, in that condition x will be xs. Okay, so xi and xs, two notations are used. So when at ice point Ti, the xi will be, the length of column is xi, and at the steam point length of column is xs. So this just we have to put this value. This Ti is equal to at steam at ice point Ti is equal to Axi plus B, and similarly at a steam point Ts will be equal to Axs plus B. Okay, so we have to subtract this equation 1 and 2. If we subtract 2 minus 1, we get Ts minus Ti is equal to this A into xs minus xy, xs minus si. This is therefore this constant. We have to find the value of constants. Okay, so first of all, we are finding the value of constant A. That means A will be equal to Ts minus Ti divided xs minus xi. Okay, this is the value of first constant. Now we have to put the value of A in any one of the equation. If you put the value of A in equation 1, in that condition we will get value of P. This is Ti into xs minus Ts into xi divided xs minus xi. So after putting the value of A and B in this equation, in this main equation, so we are getting this is the equation. T is equal to, this is the equation we are getting. Okay, right, T is equal to Ts minus Ti into x minus Ts into xi minus Ti xs divided this one. We know that Ti is 0 because Ti is this ice point and Ts is 100. After putting this value, we get that this T is equal to x minus xi divided xs minus xi into 100. Okay, this is the main equation we have to remember. This equation will be used frequently in solving the problem. So before 1954, this is very important points we have to remember. Before 1954, two reference temperature, one is ice point and next one is steam point were being used. Ice point temperature is 0 degree centigrade and steam point temperature is 100 degree centigrade. In that condition, in this equation, the temperature is linearly varies. So at ice point and steam point, this is the main equation, T is equal to x plus b. At ice point and steam point, the length of column is xi and xs respectively. After putting this value, if I find value of a and b, and just we have this whatever value we get this in this after solving this both equation, if you put T is equal to x minus xi divided xx minus xi into 100, that is T means at any arbitrary temperature T, length of column is x. Okay, so x is corresponding to T. X is length of column corresponding to this temperature. Xi is length of column corresponding to ice point temperature, and xx is the length of column corresponding to steam point temperature. So this is very important equation and this is very easy to remember. T is equal to x minus xi. We know that the length of there is some order in between x, xi, x and xx. This is temperature. So lower temperature is ice point. Therefore, then length of xi is very smaller is than that of. Okay. So in that condition, T is equal to x minus xi divided xx minus xi into 100. Right. Now we come over the next reference. This is the method used after 1954. Well, that means before 1954 some different reference were being used, and after 1954 some different reference temperature is used. So after 1954 it is seen that it might be observed that after 1954 temperature measurement was based on single fixed temperature instead of two different temperatures. After 1954 only one single temperature were used. This is the triple point of water. This fixed temperature is called triple point of water. So what is the difference between the temperature measurement before 1954 and 1954? Before 1954 two reference temperature, that is ice point and steam point were being used, but after 1954 this only one reference temperature, this is called triple point of water, is being used. What is now it is a very important question. What is triple point of water? Triple point of water is that temperature at which this solid, liquid and vapor phase, all three phases will coexist in equilibrium condition at this temperature. That means it is that temperature at which all three phases of water, that is ice, water and vapor, all three will coexist in equilibrium condition. This is called triple point of water. This temperature is known as 273.16 degree Kelvin. This triple point of water is fixed at 273.16 degree Kelvin. So in that condition, temperature is relative to pressure. You know that PV is equal to MRT is for fixed volume, is volume fixed. In that condition, temperature directly equals to P. So if you remove this proportionate, this temperature will be equal to C into P. Okay. So this we know that at triple point temperature, this let us suppose this pressure corresponding to this triple point temperature is PTP. That means if at TTP, at triple point temperature, TTP is equal to C into PTP, therefore this value of C will be equal to TTP by PTP. Okay. So now we have to put the value of constant in this equation, because whatever constants is there, we have to find the value of C. So if you put the value of C in this equation, we will get temperature is equal to TTP by PTP into P. That is this, after arranging this one, this is TTP into P by PTP. Okay, we know that this triple point temperature is 273.16 degree Kelvin. So therefore this temperature T is equal to 273.16 into P by PTP. Okay, this is important formula. T is equal to 273.16 into P by PTP, where P is the pressure corresponding to this temperature. Okay, what is P? P is the pressure corresponding to this temperature, and PTP is the triple point pressure corresponding to triple point temperature. Okay, so this is important. This the triple point temperature is equal to 273.16 degree Kelvin. Okay, so this is the all about these different methods which are used before 1954 and 1954. Thank you. We'll meet in next session.